Hi friends and my dear students. Today 12th Physics second volume 8.33 Bohr atom model and under the heading of 8.33 excitation energy and excitation potential. Today we are going to deal 5 3-mark question, very important 5 3 marks. All are very important. The first one, what is in the excitation energy? The second one, excitation potential. Suppose you want to understand the concept clearly, you have to consider the ground state, n is equal to 1 in the ground state. Or you have to imagine n is equal to 2. This is called first excitation energy. First excitation energy. When n is equal to 3, this is called second excitation energy. The energy in the first excitation energy is called E1. The energy in the second excitation energy is called E2. Whereas in general, you can write when the electron are in the first orbit, the energy of an electron is called E1, whereas in the electron in the second orbit, it is called E2, whereas in the electron in the third orbit, it is called E1, E2 dash 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 dash. Here the same letter again repeated here, but the definition is before. This is called first excitation energy. This is called second excitation energy. If you put another third E3, here E3 means the third excitation energy. Third excitation energy. So what is in the excitation energy? Now, you want to bring this electron in the lowest energy level to the first excited state. Then you have to spend some amount of energy. The amount of energy required to shift the electron from the lowest energy state to the highest energy state or first excited state is called excitation energy. Is called excitation energy. This is a very important 3-mark question. Now, we want to derive an expression for excitation energy E1 that's equal the difference of this energy level. First excitation energy. First excitation energy. Excitation energy E1 equal E2 minus E1. That is equal E2 minus 3 Asper Niels Bohr atom model. We already derived an expression for E2 minus 3.4 electron volt minus of minus in the E1 minus 13.6 electron volt. Now 3.4 electron volt minus of minus plus 13.6 electron volt. Then you adding these two, this one is minus, so that 10.2 electron volt. This is called first excitation energy. First excitation energy of an electron, and it was denoted by E capital 1, excitation energy. In the same manner, if you want to find out E2, the second excitation energy, E2, that is called E3 minus E1. That means when you bring this electron from the n equal to 1 to the level of n equal to 3, the amount of energy required to bring this electron from the orbital of first orbital to the third orbital or second excited state energy level. Second excited state. This one is called first excited state. This is called second excited state. This amount of energy is called second excitation energy. That's why here E3 minus E1. E3 we already, as per this work, we know the value of minus 1.51 electron volt minus E1 minus 13.6 electron volt. Now minus 1.51 electron volt minus of minus plus 13.6 electron volt. 13.6 electron volt. Are you clear? Now we have to subtract from this positive to the negative, then we get 13.6 1.5190 12 about 12.09 12.09 electron volt 12.09 electron volt, or you can say simply 12.1 electron volt. This is almost equal to nearer the value, that's equal to 1. Therefore, the second excited state energy level E2 is, the energy of this E2 is equal to 12.1 electron volt. These are all, we are talking about excitation energy. Excitation energy. This is not excitation energy, the energy in the orbital. Here when we say normally E1, this is the energy of the electron in the first orbit. When you say E2, the energy of the electron in the second orbit. When you say E3, the energy of the electron in the third orbit. For here, excitation energy, first excitation energy, second excitation energy, third excitation energy, that you have to calculate by means of this way. This is, if you are going on, you can find the value of the excitation energy of En like that. En like that. This is a very fundamental equation. Now we have to clear the definition once again. The energy required to excite an electron from lower energy state to any higher energy level is known as excitation energy. Is known as excitation energy. This is called first excitation energy value. This is called first excitation energy value, called 10.2 electron volt. This is called second excited state energy level, E2. This is called second excited state energy level. Now, if so, what is the excitation potential? Excitation potential is nothing but is defined as the excitation energy per unit charges. Per unit charges. Suppose if you want to find out the value of excitation in the first excitation potential in the first excitation energy level, then you have to divide by E, that's all. That means excitation potential is defined as excitation energy per unit charge. Per unit charge means the total charge of an electron is called E. Therefore, E1 by E, that's all, by into electron volt. This is the method. This is called excitation potential. Excitation potential. Okay. Now we have to calculate the excitation potential. These are two things are excitation energy. Now we are going to derive an expression for the excitation potential. What is meant by excitation potential? Excitation potential is defined as excitation energy per unit charge. Per unit charge. Suppose you want to find out the value of E1. E1 is known as, that is called E into V1. V1. That is, if you say first excitation potential, this is called first excitation potential, or V1, that is equal to E1 by E. This is called first excitation potential. Excitation potential. First excitation potential. V1 is V1, capital V1 equal to E1 by E. We already derived an value of first excitation is nothing but 10.2 electron volt. 10 point. Pass panniya. The first excitation potential, therefore V1, you have to bring this value of charge in the left hand side, E1 by E. But we know the value of first excitation energy, it is nothing but 10.2 electron volt divided by E. E cancel. That's equal to 10.2 volt. This is nothing but V means volt. Electron volt. Here, when E is cancelled, then it is nothing but the first excitation potential in volt, in unit of volt. Similarly, you have to calculate the second excitation potential. Second excitation potential like this. For example, 12.1 electron volt by E. This is 12.1 volt. This is called second excitation potential, and so on and so on. This is two very important 3 mark, and this may be asked in the 1 mark also, and very important for NEET examination also. So you must clear about this concept very thorough manner, then only you have to answer for all question. 3 mark, 1 mark, and NEET exam, everything. Now, next, what is meant by ionization energy and ionization potential? Instead of excitation, we have to derive an expression for ionization. 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 Ionization energy and ionization potential. Ionization energy and ionization potential. Now, these another 2-3 marks, very important 3 marks. Now, we are going to deal about what is meant by ionization energy and ionization potential. If you consider an atom is said to be ionized, when you consider to be an atom is said to be ionized when you bring this, or when an electron is completely when an electron in an atom is completely removed from the atom. Once again I repeat, if you want to find out the ionization energy, you have to consider an atom. Then atom is considered to be nucleus in the center and positive, electron negative. It's a normal phenomena. If an atom is said to be ionized, this atom set to be ionized when you bring this electron completely kept away from this nucleus. Kept away from this nucleus or completely removed from the nucleus. That is, it reaches the state with the energy, it reaches to the state with the energy En to infinity. En to infinity. That is, first orbit, second orbit, third orbit, fourth orbit, dash dash En orbit. This is called nth orbit. Then again you have to spend much more energy to knock out this electron completely from this nth orbit to the outer. That is called excited state. That is called excited state. That amount of energy is called ionization energy. On beyond this level, the atom is not considered to be an atom. It is purely ionized. Purely, it is neutral here. Beyond this level, it is not neutral. It may be split into positive and negative, and that process is called ionization. Ionization that has happened here. That's why here the energy is said to be ionization energy. Now, the minimum energy required to remove an electron from an atom in the ground state is known as binding energy. Suppose you consider n equal to 1 or n equal to 2 dash 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 n equal to n. Suppose if you want to knock out this electron completely from an atom, then you have to require some amount of energy. That amount of energy is needed to bring the electron from nth orbit to the infinity. Nth orbit to the infinity. This is called infinity. Then the amount of energy that needed to bring the electron first to infinity or n to infinity all are same. From the nucleus to infinite. That is the amount is called ionization energy. On this stage, when initially it was neutral, here in this stage it is not a neutral, it may be ionized particle. For example, when you say hydrogen, then if you are removing this electron to the infinite, then what will become? H plus. This is called ionization particle. Ionized particle. It will become ionized. The amount required to ionize this atom, the amount of energy required to ionization of this atom is called ionization energy. The minimum amount required to ionize this neutral atom to be a charged particle, or you have to bring this electron, the energy of the minimum amount of energy required to knock out the electron En to the infinitive, then that amount is called ionization energy. That is called ionization energy. Now, we have to derive an expression for ionization energy. What is meant by ionization energy? Ionization, E-ionization is equal to E-ionization equal E infinitive to E1. That is, the electron in the first orbit to shifted or knock out completely from the atom to the infinite distance. That is why we are energy difference between the E infinity and E minus E1, that is equal E infinity is nothing but 0. at infinite level the energy of an electron is equivalent to 0. Whereas when you consider about E1, there may be minus 13.6 electron volt. Minus 13.6 electron volt. Therefore, the ionization is nothing but minus into minus plus 13.6 electron volt. This is the ionization energy. This is called ionization energy. Again, the same definition. The ionization energy per unit charge is called ionization potential. The ionization energy per unit charge is said to be ionization potential. So, now, if you consider when an electron is in the nth state of an atom, the energy spent to remove an electron from the state that is, it is ionization energy is ionization energy is minus 13.6 electron volt, or instead of that you have to write modified equation likewise. Suppose when you consider Z hydrogen atom, Z equal to 1. In general you are giving the equation E infinity to En. Suppose E ionization to the level of En, not E1, En. And what happened here? That is equal 0 minus 13.6 electron 13.6 Z square by N square electron volt. This is called R equal minus, this is minus or minus plus N 13.6 Z square by N square electron volt. This is called E-ionization. This is called E-ionization. Again you want to define the ionization potential. Suppose for ionization energy for hydrogen atom, what is say the ionization energy for when you Z equal to 1, then what about the hydrogen? Z equal to 1. Z equal 1. What is the ionization energy of our hydrogen atom? It is equivalent to 13.6 into 1 square divided by N square electron volt. N square electron volt. Or you can say that is minus when N equal to, here Z equal to 1, N is equal to also 1, therefore 1 square, that is nothing but minus 13.6 electron volt. Minus 13.6 electron volt. This is the, here E infinity to minus En. E infinity to minus En equal 0 minus of minus of minus plus. Therefore, plus 13.6 Z square by N square electron volt. When you consider Z equal to 1, N is equal to 1. Therefore, the ionization energy in the for hydrogen atom plus 13.6 electron volt. Plus 13.6 electron volt. It is nothing but E infinity equal to 0. E infinity equal to 0. That's why you have to say E equal to 0. E equal to 0 for N infinity to N. That's a very important concept. You have to understand why we are putting 0 here. When you are concerned electron in the apart from infinity, apart far away from the distance from the nucleus, then E equals 0. That's a very important concept. Now, is known as the ionization energy. So 13.6 electron volt is called ionization energy. Now, I have to define ionization potential. Now, in this case, when the ionization energy equivalent to 13.6 electron volt, then the atom will be split into positive and negative. Therefore, here H plus hydrogen ions, not hydrogen ions. It is not neutral particle. It is charged particle that is called H plus. H plus. This is called ionization. What is in the ionization? A neutral particle which converted into ionized particle. Amount of energy required to neutral particle to be ionized is called ionization energy. That is called ionization energy. Now, for hydrogen atom, the ionization energy is equal to 13.6 electron volt. 13.6 electron volt. That's a very important concept. Now, ionization potential is nothing but is defined ionization energy per unit charge. Ionization energy per unit charge. That's all. E cancel, then 13.6 volt. 13.6 volt. This is called V ionization. V ionization. That is ionization potential. Now we have to give an equation for ionization potential. Ionization potential is nothing but ionization potential is defined as ionization energy per unit charge. Ionization energy per unit charge. Therefore, V ionization is equal to V ionization equal E ionization by E. That's all. E ionization, we already derived an expression for E ionization minus 13.6 Z square by E into V volt. E here 13.6 Z square by by N square. Here E, this is called N square. This is the equation. Now for hydrogen atom, here suppose if you want to put EV, then you have to divide by E. Then again E cancel. Then you have to put minus 13.6 Z square V volt by N square. This is V ionization. Now, for Z equal to 1 for hydrogen atom, when you consider hydrogen atom, then Z equal to 1. Then ionization potential for hydrogen. Ionization potential for an hydrogen, it is nothing but plus 13.6 1 square by 1 square into volt. It is nothing but n square. Therefore, plus 13.6 by n square volt. This is called ionization potential for hydrogen for hydrogen atom. For hydrogen atom. Now, in your textbook, there may be a fantastic table as shown in the figure in page number 156, table number 8.1. Table number 8.1. From this table, you can calculate, you must know the value of each and everything as denoted by 8.1 tabulation. That's very important for entrance as well as 1 mark questions. Or you must clearly physical quantity, quantity, ground state, first excited state, second excited state. Then radius Rn is proportional to n square. Rn is proportional to n square, or you know the value of ground state 0. Already we derived an expression for radius of an atom. It is given by 0.529 Armstrong. In the first excited state, then 4. 2 square means 4. Then you have to divide by 4. Then that is equal, multiplied by 4. That is equal to 2.116 Armstrong. That is 2.116 Armstrong. Then 3 square 9. You have to multiply by 9. Then that is equal to 4.761 Armstrong. Likewise, this is called radius. Then another one, velocity, which is nothing but Vn is proportional to n power minus 1 or 1 by n. You can say this value is equal to 2.19 into 10 power 6 meter second power minus 1. 10 power 6 meter second power minus 1 in the ground state. In the first excited state, this value is equal to 1 divided by 1, that is equal to 1.095 into 10 power 6 meter second power minus 1. In the second state, this value is equal to 0.73 into 10 power 6 meter second power minus 1. This is the velocity. The total energy